Good morning. Today, we're going to talk about Bernoulli's differential equation. Have you heard of it before?
Good morning. I've heard the name, but I'm not entirely sure what it is. Could you explain it?
A Bernoulli's differential equation is a first-order differential equation of the form dy over dx plus py equals to q y to the power n, where p and q are functions of x, and n is any real number.
It looks similar to a linear differential equation, except for that y to the power n term.
Exactly. When n equals 0 or n equals 1, the equation simplifies into a linear form. But when n is non-zero and n not equals to 1, it's nonlinear because of the y to the power n term.
So, the presence of the y to the power n term makes it nonlinear when n is not equal to 0 or n not equals to 1.
Yes, however, the equation becomes linear if n equals 0 or n equals 1.
I see. So, how do we solve it when n is real number except 0 and 1? It is non-linear in this case.
Great question. The key is to reduce it to a linear form using a substitution. Let me show you how. The differential equation dy over dx plus py equals q y to the power n. Now, dividing throughout by y to the power n, we get Now we make a substitution. V equals y to the power 1 minus n. So, dv over dx equals to 1 minus n. Y to the power minus n dy over dx. Now, y to the power minus n dy over dx equals 1 over 1 minus n dv over dx. Substitution in the equation gives dv over dx plus p 1 minus n v equals q 1 minus n, which is now a linear differential equation in v, and we know how to solve linear differential equations using an integrating factor.
That makes sense. Once we solve for v, we can substitute back v equals to y to the power 1 minus n to find y, right?
Correct. That's the general process. Let's try a quick example. Solve dy over dx plus 2 over x. Y equals 3 over x squared, y squared.